I'm Peter. I'm a Dutch JavaScript hacker. I work for Zebu. We make JavaScript applications cutting edge. So we work on mobile, basically. And we can do pretty much anything. We also sponsor JSConf, by the way. So much for that. So I'm going to talk to you today about tooling. And tooling, we all use tools in our everyday life. Whenever we use a text editor, whenever we use an IDE, testing frameworks or whatever, they're all tools, and they're all, I would say, very important to our line of work. And it occurred to me that last year that the number of tools are actually pretty, well, not limited, but I would like to see more. And so I'm going to try and persuade you and to show you how easy it would be to create new tools and to persuade you to, make new tools. So I'm going to talk to you today about Xion. Xion is a static JavaScript analyzer I created using a handwritten parser. And based on a handwritten parser, I can infer a lot of stuff. And most of it is pretty trivial. So I'm going to try to quickly do the demo thing. Of course, it doesn't work as intended. All right. So this is interesting. This is basically what Xion is. As you can see, let's see, there's a pop-ups. It will give you more type information. It knows, it has static references to variables or this or whatever. It does inference, it sees that, well, right now it doesn't throw, but if I would throw, I don't know, some string, then it will say throw string. If I return, currently it returns an object and something it doesn't know the type of. It has all kinds of tools right here: Minification, beautifier, I don't know, generating JS docs, whatever. And it can all do that. So that's basically what Xion is. And let's get back to the presentation. All right. Next. Yeah. So what Xion does is not magic. It's just a set of rules. You get the information from your source. You know the structure of the source. And so you can apply these rules and infer, well, data from it. Warnings, errors, or derive tools from them. So these rules are applied to the input. You get the input rules, you apply rules, and you get output. That's basically what it works, how it works. And Xion just displays it graphically, so it will immediately give you the feedback that you need. So the parser works with tokens. I'm going to quickly do this. I actually did this for Paul, but I don't think he's present. I haven't seen him yet. He wanted me to do this, the real way diagrams. So a token in JavaScript is the smallest piece of code that's still a single unit. It would be like an identifier or a number. Whatever the smallest unit, these are the smallest units. You only have 8 or 9 of them. And the smallest units are fetched in a greedy fashion. So whenever you have a plus, it could be a single token, right? It would be fine. But if it's succeeded by an equal sign, then that would also be a single token. It would be bigger, so it will take that and not just a plus sign. That's an important part for the whole parsing process. This is my favorite expression. I don't know why. It's just visually appealing, I guess. This is actually a regular expression divided by a regular expression. Something that was a test case for my earlier parser. So the parser tells the tokenizer to take the next tokens. All right, so it will tell the tokenizer, give me the next token, and I'll handle the rest. You don't have to worry about how that works. Just give me the next token. So let's be the parser right now. We're going to start with an empty script, so we know that we're at the start of a statement. And the first token we get is an if. We know that at the start of the statement, we're either at the start of a statement or the start of a function declaration. Function declarations start with function, so this must be a statement. In fact, it must be the if statement. The if statement can only be followed, the if keyword can only be followed by one valid thing, and that's an opening parenthesis. Anything else will be an error. The opening parenthesis is followed by a shitload of stuff. And that seems to be complicated, but let's just for now say that we're going to parse the expression and just leave it at that, right? So it must be followed by an expression. Any kind of expression is fine, up until the closing parenthesis, because that would not be part of that expression. And then the final part is the statement. A single statement, don't worry about it, you basically do the same thing as we just did with the if. And congratulations, we just parsed the if statement. There are a lot of statements, of course, but they all start with keywords. And you can very easily see that if you start with a keyword, how the structure is going to be. So the parsing is relatively easy once you get to it. So let's go for the expression. The expression is slightly more complicated. It can start with something I call a lead value, which is basically just any kind of value, like a this, or a null, or a true, or a number. And then the unary operators, the void type, type half, or delete, or whatever. So that's what an expression may start with, nothing else. So let's have this expression. It's a silly expression, I know. It's still valid. The parser will not tell you that delete new is not going to be working. You can do it. The interpreter will tell you that it's pretty much, well, actually this will work, I think. So these are the tokens. All right, so when a tokenizer is finished with it, this is what it ends up with. Any box is a single token. So we start with the operators. We start with delete and new. Just keep parsing prefix operators that, up until the point where you can't, and that would be shoe. And so when we find shoe, we have the lead value. All right, in this case, just an identifier, just a variable. We don't need to know what the value is. We know it's an identifier. Identifiers, lead values are, may be followed by property access or call expressions, which are, in all cases, either a dot, the opening square bracket, or the opening parenthesis. Those are the only three that would be valid for, it would be valid for this part of the parsing. We find the opening parenthesis, so we know we can now parse an expression and then the closing parenthesis. We continue, we loop, do the dot, and then we do the same thing. With dot is an identifier. And of course then the opening square bracket with another expression. So Xion tries to throw you comprehensive errors. Something that annoyed me, at least in the earlier days, that errors were often, just missing identifier or missing this. You have no context, you had no way, not really a way of knowing what was actually wrong, It's still, you can't always know. Sometimes you're just missing stuff or whatever, and you can't really guess or know what should be following, but often you can. Right now, the missing thing, it would be the name, because a function cannot start with a function expression. So after the parser is done, this is what's left. Basically, my parser just releases a stack of arrays with objects. Every object is a token, and the stack of arrays is much like an AST. It's not like the classic AST, but it's something that Xion works on for almost everything. This is the actual AST. It has lots of properties, lots of meta information, which you can easily see with the click of a button in the GUI. So Xion also releases two token streams. It's a so-called white and a so-called black token stream. The white token stream contains the white space, the line terminator, and the comments, whereas the black token stream doesn't. The parser doesn't really care about those. It only cares about line terminators and only to apply ASI. So the first thing I started with was variable declarations, and that's the easy part. The parser already releases, or already gives me a scope chain, which has all the variables that are declared, including parameters or like function expression names or whatever. So I can all find that back in the scope. If it's not in the scope, then it is an implicit global. So it will warn you for that. If you do a double declaration, the parser goes from left to right. So the first time it finds the declaration, it will mark it as being declared. If it finds the second declaration for the same name in the same scope, you have a double declaration. And you might want to be warned for that, because this example is trivial, but now, imagine you have like a long piece of code and you're inside a loop with an I, and you want to do another loop with an I just out of, you're not even thinking about it, and you're suddenly double declaring I and you have a bug in your code. If you would have a warning for that, save you like 2 minutes. Basically, the same goes for the premature usage. If you're using a variable prematurely, it might indicate a problem, at least in coding style, in my opinion. But it might indicate a problem, as well as undeclared variables. You just have forgotten or mistyped it or whatever. So let's take look at some simple examples for what Xion does. Whenever it finds the closing parenthesis of a statement header, it checks the next token. If the next token is a curly brace, no problem, nothing is reported. If it's not, you have basically two options. Either it was followed by a line terminator or it wasn't. I personally prefer the second version, so I don't think it's an extra error, but you can still get a warning for it. You can disable it. If there was a line terminator, then yeah, you get a bad indentation warning. The next one is like an assignment in the header. All we have to do is find a token for an equal sign, and since we're parsing from left to right, we know when we are in or when we are not inside a statement header. So it's really simple to just, there's a flag, check the flag if we have a token with an equal sign, and that's it. And throw a warning. Same for a weak comparison. Find double equal signs as a single token. And you have a weak comparison. There's no other reason for a double equal sign. If you have a triple equal sign, you don't. This is a typical Douglas-Crockford warning, but it's in there. You can disable it if you don't like it. There's an exception for type of. Type of always returns a string. And so, well, I'm fine with double equals, but that makes it slightly more difficult. So where I use the token string for all the previous things I just explained, I have to use the AST because I need to jump back one expression, and that's too difficult to just do in a token string. Assignment to this, if you have an equal sign that's previously, that's following a dis token, and that dis token is a lead value, you've got a problem in your code, basically. So you get a warning. If you're a regular expression followed by a call expression, it's valid, I think, still in Firefox, or maybe they were removing it. But you might have a problem in your code, so you get a warning for this. So this is what Xion does. It will just give you warnings for possible indications of your code. You can disable them. I'll just show you in a second. You can disable every warning you want to. Flow breakers. Flow breakers can cause dead code, and I say they can cause dead code because in the first X is not dead code, of course, because foo might be false. In that case, it doesn't return. In the second one, it does, because both the if and the else, they break the code. The second X is never executed. It's impossible, and you can just prove that statically. So you don't have to run the code to know that X is dead code. And Xion does this, and it does it on more complex levels. It checks for switches, it checks for try-catch properly, all that magic. So it does type inference. A simple example is this. At any time you assign a value to a variable, you can probably infer the type if you know the right-hand side type. In this case, we assign a number to X, so we know that X is a type of number. In the second assignment, we know that X is going to be a string at that point. In the middle example, we might still know that it's a number, but for all intents and purposes, we show every type that X might be. This is a trivial example, but there are more examples where this makes, I guess, makes more sense, because not every time you're able to tell whether a variable changed a type. Type inference can be complex. Type inference. The type inference makes it easier for operators. If you have a multiplication, it always returns a number. There is no way it doesn't return a number. It might be nan, but that's okay. That's still a number type. And so the same goes, so the top two always return a number, so X and Y are always a number. The third one is more difficult because the plus might return a number or it might return a string. Xion will try to check whether the left and right are both of number. In that case, it will return a number. But if it doesn't know, or it knows that one of them is a string or an object or anything else, then it will just do a double typing. Some operators are transparent. And these are trivial examples, but also very silly. You'll hardly ever see them. But Xion doesn't evaluate the types. So it will know that null is type of null. It will know that true is type of Boolean. And it will just say that, okay, for X is either type of null or type of Boolean. And we'll do this in any kind of expression. The same goes for the double AND. It just returns both types because that's basically what could happen, as long as they're not literals. There's a simple navigation. In the bottom right-hand corner, there was a navigation part. If you click on the number or the arrows, you can just click through all the warnings and errors and whatever is out there. And you get a blue circle, and you can jump to it really easy, really fast. And that, in my opinion, that was really missing for the classic, the classic linters. The JS lint, you only get text. You have to go back to your source code, line 5, character 55. What the hell? This made more sense to me. If you click on the description, for some descriptions you get a more detailed pop-up with like a grouped thing, and you have a separate nav for that. So if you just want to know where the implicit globals are, you can just go through that, and you don't have to go through all your millions of warnings. There are quite a few of these warnings, and you can configure them all. If you don't want to see them in the GUI, just disable them. Just tell them, I don't want this. I don't want to see this. It will still check for them under the water, but in the GUI it will not show up. So there are a few tools. How am I doing on time? Oh, that's not so bad. There are a few tools. One of them is Pragma. I've been playing for this for a while, and basically allows you to pre-process your code when you want to push it to production. So you have some unit tests in there. You obviously don't want your unit tests in your code, but you also don't want to either do a regular expression on your code, because that's not as safe as it could be. And I think this is really nice. Xion knows about these pragmas that I defined, and it will dim them. So it will not really, it will not clutter your view. You'll just tend to ignore it because you're more prone to look at the colors than the grayed out area. And it will still be JS. I mean, when you run this code, it will just do the assertion. But once you press the Pragma button, it will remove all the Pragma statements, and whatever wasn't defined is removed. So all you're ended up with is the debug statement, because you were defining debug up there. Macro is a similar kind of thing. I guess it's more for constants, but sometimes, I don't know, for production you might want to obfuscate your code, or in my case for the parser, it's much faster for me to just have a literal rather than a global lookup. But for development, it makes my life easier if I just have more sane kind of things rather than magic numbers. So that's where macros come in. You can either do it like the top one, just have a literal. It will only search tokens. So if you use the name in a comment, it will not replace that. But if you use it as a token, it will replace the token with whatever you give. The second version is slightly more complex. You can do like identifier.identifier, and it will replace those two, because I think that's a very common pattern, just to create an object literal for the flags or for the constants. On the right-hand side, you can see that the flags object itself is not removed. I guess you could do that, but yeah. Minification, of course, is probably like the first thing people do once they get their hands on these things. It does it. There's a special case, thanks to Fabian. He's probably somewhere around here. He asked for this. It replaces the semicolon with a return, which makes your code still minified, but still slightly more legible in case you want to debug it. You can actually shrink variable names, nothing special there. And something I actually don't see in minifiers is that it will also cache property names if you enable it, which reduces size, but of course adds the lookup time for global variables. Still, in most applications, that won't matter, and you can often, for a 100K script, you can easily save like 10 or maybe 20K. Beautification, simply proof of concept. Actually had to rewrite my AST for that, or at least not rewrite it, create a new AST, because rewriting means that you have to have a single function for everything you rewrite. I couldn't do it with my original AST. It's not configurable simply because there are no other options, but it's easy to extend them simply because there are other functions. It will save and load your code to local storage. Unfortunately, you're not currently able from the browser to directly save to your file system. And I mean the actual file system, not your local sandbox file system, the local file API, but you want to load a file and then save it back to that file. That's currently not possible, at least not to my knowledge. If that is possible, please tell me, because that would be like a killer feature, I guess. As I just showed you, it can generate JS docs. It will generate JS docs from functions or variables. Variables are optional, by the way, because it will clutter your code, kind of. It will use the type inference and just generate those JS docs as is, as it thinks it's right. And, well, I don't know, that works. It will regenerate existing JS docs and will do proper indentation. There are some trivial tools, like converting your code to a JS string, which is, I don't know, something that I tend to do every now and then. Convert a string back to code. You can do a bookmarklet. You can trim trailing white space, because that's a pain in most people's IDEs. You can show the raw AST, the picture that I showed you before. That's just a button. It will show you the AST if you're really interested. Any hash part in the URL will be put inside the code editor, so you can easily link to it. There are some tests, both for the parser, fuzzer, which just tries and tries and tries. Helped me out in a few bad spots. Right now it seems to be very stable. And there are not unit tests, but tests for checking whether the warning is there. But that's literally like 2 weeks old, so it's not very complete. There's a fix hoisting button which will collect all variable declarations, remove the var statements, and just move all the declarations to the top of your function. It's best practice, I guess. It can do the same for function declarations optionally. It will refactor them properly, indentation, everything. And, well, if you want to do that, you can easily just do it for your entire code. Code rewriting, it can inject function expressions, or no, just expressions with a function call to every statement. And that function will then be called with a unique statement identifier. And I actually use this to create a live profiler, which I'll show you in a second. There are just rules. So for every kind of statement you have, there are simple rules where you can just add the expression, the function call, and it will be equivalent in the execution of the code. Of course, it will be slower. This is a feature requested by Matthias, operator precedence tool. You have a stupid expression, and you can add parentheses automatically to disambiguate the whole expression. This is, I guess, more a learning tool than an actual tool you'd use in your code, but whatever. Branching tool, that's a pretty cool tool, actually, though much useless. If you have a simple function like this, a stupid function, sure, but if you have a simple function like this, there are actually 2 code paths in this function. There is both the code path where it evaluates x and returns 5, and it should still evaluate x and then return 6. Well, but there are 2 code paths, and it can do this for pretty much any kind of flow-breaking construct in the function. If you have larger functions with a lot of code paths, beware, because it will take some time to compute all of them. This is a tool. This is my newest tool. It will declare your missing prototype instance variables. Say you have like the prototypal way of doing things. You declare variables just like this x is 5, but you haven't declared it explicitly on your prototype object, and that's something you want to do because either for yourself in like 6 months or for other programmers in your project, they will want to know which instance variables exist on the prototype. This tool will try to do an educated guess on what the prototype object is, and it will add the missing properties to that object. And well, I think it's the best practice to do so. Let's see, Realtime Profiler. So I've got a simple demo for this. Can be done from the browser, unfortunately, but that's okay. All right, so demo. All right. Crap. So this is the beautified code. It's a JS1k from the first edition. Pretty much a random one that would work like this. So nothing special happened here. It's just Xion with code in the editor. I can press this button now, the visual profiler, and it will show you the JS1k. And on the right-hand side, you can see that the code is highlighted, which was ran the most. It actually is live. So if this code would now switch to, say, executing this more, then this would become red and this would dim slightly. So this is real-time. A real-time heat map on the client side, no node, no nothing. Woo. As you can see, these are the tests, and not all of them are finished. I mean, they're all working. They're just, these are placeholders, so don't worry. Let's get back to the presentation. Yeah. All right. So the client server is pretty much detached. Client server, I mean the parse, the GUI, and the post-processing. So it's very easy to port this to a server environment or to embed it in another application. You just pick the parser or, yeah, 5 minutes, thanks. Just pick the parser or whatever. Integration is easy, and the API is very simple. The parser is reasonably fast. Zeph did a benchmark. Actually, I can quickly show you a simple. Of course, this is bad because I haven't. Let's see. Well, you know what? Let's not do that. But there's a benchmark you can run. On my laptop, it does a megabyte of JavaScript in 700 milliseconds, completely parsed, which blew my mind the first time I saw it. I didn't know JavaScript could be that fast. Yeah, so tooling is important. Make more tools. It's fun. It really is fun. Once you get into it, it's awesome to create these tools. It's, you know, some things are trivial to create. Some things are more difficult to create. But in the end, you'll help yourself, or maybe something else. You know, you can make either tools for your active day programming, or you can make tools to help other people. You know, you can create the operator precedence tool, whatever. Make more tools. I'd love to see more tools, and I think that's something that is, you know, picking up. We saw Cloud9. I can see the what? There was another ID there. It's also very good. So, yeah. Anybody remember this guy? Yeah. All right. So you know this catchphrase, right? All right. So, we've been wondering about Xion, what to do with it. And that's it. Xion is now open source. I will push the actual code in a second. But you can hack on it. You can look into what it does, and you can push new updates or whatever if you want to. Thanks for your time.